Hello everyone, this is Tejas Krishna Patil from Pillai College of Engineering, New Panvel, and this is my presentation for EMERTXE Foundation under the project IoT based home automation system. Let's discuss the topics covered during the internship. During the internship, C programming was firstly taught. Under that, we covered keywords used in C programming, operators, data types, arrays, pointers, functions, and storage classes used in C programming and many more concepts. The next concepts taught was C++ concepts. Under that, we learned OOP means object oriented programming concepts. Then we were taught IoT. Under IoT, we taught introduction to IoT and architecture of IoT. In this, all the layer of architecture and all we taught. After that, embedded system were taken. Under embedded system definition, types of embedded system, components of embedded system, and uses of embedded system were taught. After that, we covered peripherals. In peripherals, LED, which is used in PiximLab, CLCD, ADC, all these terms are used in PiximLabs. And after that, we learned Arduino Uno IDE. This is the IDE in which we can code in C language and connect our code to PiximLab and operate the smart things. Next, simulation tools used were Arduino IDE, PiximLab, Null Emulator and Blink IoT application. Arduino Uno, it is a Arduino integrated development environment. It contains a text editor of writing code, means we can write code in Arduino Uno, a message area, a text console, a toolbar with buttons of communication and a series of menus. It connects to the Arduino hardware to upload programs and communication with them. Means using Arduino Uno, we can write code and connect that code to PiximLab and smart devices to communicate. Other tool is PiximLab. PiximLab is a real-time emulator of development boards with MPL, ABX, AVR, GDB, debugger integration. PiximLab supports microcontrollers from Pixim, SimWare, USISP, and USTM32 and EQM ESP32 and GPSim. PiximLab has integration with all these microcontroller programming boards. Null emulator. Null emulator is used to build serial communication between Arduino Uno, PiximLab and the tank used in project. After that, Blink IoT application. Blink IoT is a mobile application used to control tank, lights and all these things in the project. Let's turn to our project, that is home automation system. Home automation system is a technology solution that enables automating the bulk of electronic, electrical and technology based tasks within a home. A home with an automation system is known as a smart home. In this project, we are making a normal home as a smart home and operating the lights, tanks and all these things using a mobile app. In this project, we will automate three things, that is garden lights, temperature control system means the temperature in the house, and water tank, that is water tank which is in the house it will be automatically controlled. Garden lights, we have to turn on the lights at night and turn off when in the morning sunlight automatically. Means when there is less light in the environment, that is at the evening and night, the light will automatically on and once the sun rises the light will be automatically off. After that, temperature control system, reading the temperature from sensor and displaying the temperature on goggle in Blink IoT app and on the CLCD. Means the temperature in the house in the environment will be calculated, and according to that the things were operated. We have to control the cooler and heater using the buttons on Blink IoT app. If there is more heat, then the cooler will be on, and if there is more cold, the heater will be on. If the temperature is more than 35 and the heater is on, then turn off the heater and send notification to Blink IoT app. Here 35 is just an example. The value may vary, and displaying it on the CLCD. After that we will control water tank. Read the volume of water in the tank and display it on the gog width in our Blink IoT application and on CLCD. We have to control the inlet and outlet valves of the tank using buttons of Blink IoT application. If the volume of the tank is less than 2000 liters, then the inlet valve and send notification to Blink app and display it on the CLCD. Here again 2000 liters is just an example. It will be depend on us how to which take the value. Peripherals required for the project: LDR, sensor and LEDs to read the sensor values and based on reading vary the brightness of the LED, that is garden lights and all. Temperature system, it consists of heater, cooler, LM35, that is temperature sensor. We can read the temperature from the temperature sensor. Serial tank, we can read the volume of the water in the tank through serial communication. This is the Arduino ID and the screenshot of the first home page of Arduino ID. Here we can write the code, and the boards can also be selected. Like if we open this arrow, the boards can be selected. This is the screenshot of Pixim Lab simulator use. Here the code is connected. Thank you. Now let's move towards the simulation of project. So first part of our project is garden lighting. This is LDR. When resistance of LDR is very high, the garden light should turn on. It means that it is a night time and LED will glow. And vice versa, when we decrease the resistance of LDR, the light should turn off. Light has turned off and it is daytime. Okay, so next part of our project is about the temperature, and as we can see, this is the Blink IoT app. So when I turn on the heater, the temperature should be 35, and after 35 the heater will turn off. Then we will get a notification in mobile that the temperature is above 35 and the heater will automatically turn off. Looking about the cooler, when the cooler is start, the temperature decreases. We can see that at room temperature, that is 27.4, the cooler automatically turns off and we can see the notification. This is about the temperature. So the last part of our project is about the cereal tank. So this is the cereal tank, and the maximum volume of the cereal tank we can store is 3000 liters. Initially the tank is completely filled, and since it is completely filled, the inlet is off. When I turn on the outlet valve, the water will go and the tank will get empty. we can see that the water is decreasing. And according to this, below 1500 the water level, the outlet should turn off and the inlet should turn on, means the inlet will it will get turned on. It shows that water level is less than 1500 liters and inflow is enabled. Now if we turn off the outlet, the water level will increase as the inlet valve is on. And when the tank is completely filled, we can see that the inlet valve is also off and the notification has pop up that inflow is disabled. So we can see that the inflow is also off, and inflow will get off only when and only when the volume of tank is full, that is 3000 liters. And if we turn on the outlet, we can see that the water is going out. And if I turn off the outlet, we can see that the water level is not below 1500 and inlet is not on. So this is about the project. Thank you so much.